What's up?
Nothing much. I'm just finishing up like my, I guess like last minute study sessions. So I've just been watching like video reviews. Like right now I'm watching this guy go over the psych section of
Hmm.
the milestone review sheets, which I feel like will be very helpful.
Yep.
Um, and I did all of section bank 2. And I'm almost done with section bank 1. Like I'm gonna finish that a little later and like review it and hopefully that'll help me get some extra points.
How much more of that do you have?
I have to do like the half of the bio section, half of chem, and then like all of psych soc.
Okay. Um, and you think you'll be able to like finish that today?
I feel like I'll probably yeah, probably. I mean, I'll be working till like 12:01, and I think that's when my cutoff is going to be. So, yeah.
Got it. Yeah. Because tomorrow, the day before, your test was on Saturday?
Mm-hmm.
So yeah, tomorrow you don't want to be doing any like passages or questions or anything, just passive review like Anki, looking over notes. You can look through like the quick sheets, um, PDFs that I have in the PDFs folder. Um, how's like your sleep and stress and everything?
It's better. Like I feel like before I wasn't really like sleeping too much. Like last week I was like kind of up and tweaked, but now I'm like calmer.
Mm-hmm. Good, good, good.
Like whatever happens, happens.
Mm-hmm.
Yeah, I'm yeah gonna go and put my best foot forward, and I hope for the best. Like I feel like I'll do okay. Like I think I have a chance to do pretty well. I just have to make sure that I focus and like I don't let them catch me with like any tricks. And yeah, tomorrow I'm probably just gonna work on figuring out like the equations that I'm gonna write down on the during the tutorial on the equation sheet that I'm gonna make, and I'm just gonna focus on solidifying psych soc. Do you suggest that ours practice? Um,
Sorry,
I
say
feel
that
like I
again.
haven't done
Chuck.
too much. I was saying, do you suggest that I do any like cars practice? I feel like I haven't done too much over the last week. I mean, like I feel like my car scores are like consistent. Like I don't know.
Um, so if you're gonna spend so like since you only have like basically like today and I don't really want you to be doing like any like passage based stuff tomorrow, and since we're prioritizing the section bank, I think that yeah, I think you're good with good for cars for now. Um but but yeah, so I wanted to make sure so you're like, getting enough rest and you're because like that's a big part of it. So like make sure you're getting enough rest and everything like dialed in, like whatever, do the same, like whatever you're eating, whatever you're drinking, like just have it be like the same as on test day. And um and so for today we can go over we could actually look through like the quick sheets together and like kind of like look over topic areas that you may not um that you might need some help in. We could also do like questions if you have questions from like the section bank or the practice test that you took. Um, yeah. Or we could do both, whichever. What would you like to do?
Oh. Well, I do have a question from the section bank just because
Yep.
like we're doing it recently. Also, like I'm so bummed that Jack Westin got rid of their
Oh yeah. Yeah.
it's so sad. I was like I was so bummed because I was gonna like redo the Chem Phys section that I did in my first
Yeah.
I don't know, my first exam. I was gonna redo it,
Oh,
but
the blind review.
yeah, well yeah, I was just gonna well because like you could hide the solutions, I was just gonna like take do the questions over again and see if like my score changed. But I was like, okay, I guess not.
Yeah, yeah. And it's sad because like the AAMC format is like it makes no sense at all, right? Like first like if these are the people who made the MCAT, why make make it so that it's not in the MCAT format? And it's like you can't even if there was a way for me to like block out part of the passage or
Yeah.
then that would still work, but they insist on making it so that you can't like let's say that I try to blank this out, so I would do something like this, right? And if there were just like answer choices, I could block them out like this, but they make it so that they make the color of this entire thing, green.
Yeah, it's
So
hard.
I can't it's pretty yeah, pretty
Just goofy.
Mhm.
So for this question, like I feel like it's just like the OChem foundations that I'm still like I found a couple OChem videos that I'm probably gonna watch like later tonight.
Sorry, you're
Like probably just like watch it again tomorrow. Like I'm not gonna any more practice questions. I'll just take this off. Like, I'll do it.
hmm
Um, I think I was saying I found a couple of OChem videos that I'm gonna watch later just to like go over the this stuff, but I don't know, like but I'm not gonna do any more practice questions for
Yeah, so do you happen to have the spreadsheet that um I made for you open?
oh yeah, wait, hold on.
Yeah. Okay, so what you're going to be doing, like, in these last couple of days is, yeah, exactly. Like something like, yeah. So now you could do like Ctrl+F and type in like amide. And so this shows you like, yeah, what you need to know. So these like last few days, like today and tomorrow, or well, I guess today you're gonna finish the section bank or attempt to, but like for tomorrow or in general, like like so for that question that you showed me, like they talked about amides and anhydrides and stuff. So you want to be thinking like this, like okay, like what do I need to know about this topic? You check here and you need to know, and you need to see that it's like to be able to see things in categories, right? So like an amide is a type of carboxylic acid like derivative, and so are esters, and so we also need to know about lactams and lactones, which are just cyclic amides and esters respectively, and anhydrides. And so this shows you like what you need to actually know, so you know exactly what to look for. And I think I don't know if I shared like this resource with you before, but it's a pretty, here, I'm gonna put the link in the chat. It's a really good, concise um website that goes over organic chem. Yeah, so particularly for organic chem. So yeah, you can kind of like scroll through and you'll see that they're separated based on subject, right? So like alcohols, aldehydes and ketones, and like you can continue to scroll down. Your carboxylic acids, acid derivatives like amides and esters and stuff. So, yeah. So I would say like when you're doing your review to have that type of workflow, like you see the question you got wrong and you see what they're talking about in the question. So they talked in the one that you showed me, they talked about anhydrides, they talked about amide. So you want to think not just like organic chem, but you want to think like, okay, it's the specific topic of acid derivatives, and this is what I need to know for amides. This is what I need to know for anhydrides, and then learn it that way. Um, and then that question also talked about, let me see it again. Um, so okay, they're also talking about extraction. Okay, here.
Hmm.
So you can go back to that spreadsheet, the spreadsheet.
Oh, my bad.
hmm And then same thing, do a Ctrl+F. All right. And now what category is it under?
Separations and purification.
Yep. And so you want to be able to classify this stuff when you read it or when they ask you questions about it. So you need to know like what is like extraction for? What is distillation for? What is chromatography for? Well, they're all separation techniques, which means, if you have a mixture and you want to separate what it's made of, you can use these techniques. And each technique um, takes advantage of some difference between the things that you're trying to separate. So you want to be thinking that way. So like chromatography. So when people I'll give you an example of like what not to think and what to think. So like, let's say that I asked someone because it's funny because like some students of mine like they answer questions like this. So if I ask them like, okay, what's chromatography? Or maybe I could try it with you. So what's chromatography?
Um, well, it's like one of the separation techniques. It's one of the lab techniques.
All right.
There's liquid chromatography.
So I'm pretty sure all of these are separation techniques, and I'm pretty sure they could all deal with liquids. So tell me what, go on.
There's column chromatography.
All right, so now you answered it exactly the way I was gonna predict, meaning if I like when I ask someone like what's chromatography, they would tell me examples of types of chromatography. But that would be like what's a book? Um, I don't know, like why can't I think of like a book? Um, like what's like yeah, I don't know, I can't think of an example. But do you know what I mean? Like you if someone asks you what something is, you can't answer that by saying these are examples of those things. It's like, okay, what's a human? And then I answer Barack Obama, Trump, um, Zelensky. It's like, wait, but what is a human actually, though? Do you know what I mean?
Yeah.
So, okay, so now you also want to be able to think. So, if you really understand something, you could describe it in a very simple way. So, all of the in if you are to separate things, right? You need to have something that is different between the things that you're trying to separate. Let's say you have like molecule A, let's say you have molecule B. Now, if they were identical, you can't separate them, right? But if they are not identical, then they're different. And if they're different, there must be at least one trait that is different, right? Because otherwise they would be the same.
Mm-hmm.
So then the technique that you use for separation will take advantage of a trait that or characteristic that's different between them, right? So, do you like ever like make your own coffee?
Sometimes.
So, walk me through the.
Um, so I'll get the coffee grounds and I'll put it inside the like coffee filter thing. And then I'll fill up the water in the pot to the level that I want. In case I want it to be like not too much water though, because
So, why do you need the filter?
I kind of like so there's no grounds in the coffee.
So,
Where yeah.
you are separating them, right?
Mm-hmm.
And what are you separating them based on?
Um, like the coffee grounds based on I guess like the side. Like I'm confused. Like
Sorry, so if you're using a filter, so what goes into coffee in general?
the coffee beans.
Yeah, so like the actual coffee part, which could be the beans or the grounds or whatever, and water, right?
Yeah.
Now, if you want to separate them, you use that filter, right?
Mm-hmm.
So what characteristics, so the filter, in order for it to actually separate them, needs to take advantage of something that's different between them. So, so like try to think like what characteristic of coffee and water.
Oh, okay. Okay. Yeah, it's like water is a liquid and coffee is a solid.
Okay, tell me a little bit more. Like,
Um,
because I mean, what if I put like soda? If I mix soda and water, like that is, it's like the coffee filter isn't going to separate that, right?
no. Um, I guess like the is it the density or um uh
So just so think about like a filter and think about if you zoomed in on it like a million times, or not that much, but you know,
um
like what, why
oh,
can't
the
you,
size?
why can't you use um like saran wrap?
Because then like the water won't be able to go through.
Okay, so
I,
what
co-
char
uh,
yeah, so in a coffee filter, what characteristic enables the separation between the water and the coffee grounds?
is it like the
So just think about like like just imagine if you zoomed in on it on the filter itself.
yeah, I feel like the water could fit through like the
Okay.
coffee.
Okay. So they're different. You're taking advantage of their difference in what?
And and well, I don't know if it's not necessarily size. It's like I guess like properties. Like how water could kind of just move anywhere or move through anything.
Um, think about zooming in again. Like what would it look like if you zoomed in?
A bunch of like tiny holes.
All right. So go from there.
Um,
So the holes let the water go through, right?
Right. Like, are you thinking like osmolarity? But then I'm like, I don't know, I feel like wouldn't water like want to stay?
Just think like just in terms of like don't worry about like science words or whatever, just on a very, very fundamental level. So here. So basically, if you zoom in on it, you get a bunch of these tiny holes, right?
Yes.
And the holes are large enough for the water to go through, but they're not large enough for the coffee to go through, the coffee bean. So that means that you're separating them based on size, right?
Yeah.
So like in this entire like exchange, like what I'm trying to show is that so like imagine like so like let's say there's a question that someone asks you. If you go right to the part of your brain where you think of examples of that question or content, it can get in the way of your thinking. So that's why I was like, just zoom in on it. Just imagine zooming in on it. And you were there. You're telling me there's a bunch of these little holes. And you were even aware that size might have something to do with it, but you ended up saying that it doesn't. But it does, right? Because otherwise, you would have the grounds go in through the filter, right? So think about it like this. A separation technique is going to separate things, and to separate things, the things that you separate must have something that's different about them. And that's what you take advantage of to separate them. So coffee filter separates the coffee from the water based on size, right? So, um, so yeah, think like remember this is like a thinking test, so you just want to be thinking like that. So all of these separation techniques, they take advantage of something that's different between them. So, for instance, distillation takes advantage of what do you think?
It's like boiling points.
Perfect. 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 Okay. Extraction.
Mm, different like solubilities.
Very good. So yeah, you got it. So typically in extraction, you're gonna have like some nonpolar like hydrophobic organic layer and some aqueous layer, right? Okay, cool. So okay, we can go back to that question. But yeah, just this type of workflow of like, okay, like, extraction. So like when you're reading this, it's like, okay, extraction, taking advantage of different solubilities. Amide is a carboxylic acid derivative. And then they say the byproduct, and this is them being really kind of mean with the way that they word it. Um, but they're saying uh to separate the amide from the byproduct of the reaction between an amine and excess carboxylic acid anhydride, right?
Hmm.
So okay, so let's say we have an amine, and this is going to be so we have okay, so we have four compounds, right?
Okay. Yes.
Well, and what are they? And you don't have to tell me like specifically, but from what they tell us.
So there's the amide is in the product. Well, actually, no, it's not in the product. you're trying to separate the amide, and then it's the amine reacting with the carboxylic acid anhydride.
All right, so those are three. And what's the other one? And again, you don't have to know.
The
Yeah,
the product of the
the
carboxylic acid.
byproduct, right? The by
Yes.
the byproduct.
Wait, so what's the difference between the byproduct and the product? Like, is the byproduct just like, is that what's left over?
Oh, so it's no different from a product, but it's like a product you're not trying to get. It just comes along with it,
Okay.
like a side effect almost.
Okay.
Hmm.
All right.
Um, but the amide would be a product, right?
Mm-hmm.
So we have amine plus carboxylic acid anhydride. Um, what's that?
It looks like a bat. It
Hmm.
and then there's a circle in the middle, a O
I think
in
you're
the
thinking
middle,
of
and
an
then
ether. Oh wait, no. Wait, sorry. Tell me again.
there's like a line and then a circle and then another line here, and then there's a double bond O in the middle on top of the carbon there, and then
Hmm.
from that carbon there's another O and then another carbon.
So something like this. Is that it?
Oh, I wasn't thinking that, but maybe I was thinking
Were
about
you?
something else.
Yeah, I thought you were thinking of this.
Yeah, I think that's what I was thinking of.
Oh yeah, yeah. So that's an ether.
Okay.
Um, so but if you're um so like let how to prevent mixing that up. So ethers are not carboxylic acid derivatives, right? And so you're expected to know that, uh so what are the carboxylic acid derivatives?
Um, Aldehydes, um,
Mm.
ketone.
So what does it mean to be like a carboxylic acid derivative?
Oh, you could be formed from carboxylic acid.
All right.
So yeah, anhydrides.
Uh-huh.
mm, Um,
So it'll be your acid chlorides or halides.
okay.
So maybe I'll do it like this first. So this is a carboxylic acid, right?
Mm-hmm.
And if you added an amine, that'll attack here, push this over, push it back, get rid of the OH part, and then you just have this, right?
Yeah, but I forgot what that's called.
Which part?
This, what this one's called.
Oh, that's a really important one. Well, they're all really important. But I already wrote down, so I'm like writing down like a list of things to for you to go over. Um, and I just wrote carboxylic acid derivatives, but this is extreme. Like knowing your functional groups is uh something you 100 trillion% need to know. So you can just Anki it after or tomorrow. But this is an amide,
Okay, yeah, okay.
and It shows up in certain types of molecules. What type?
I was also thinking, because if there was another nitrogen, then that would be like urea.
So, um, uh, well, yeah, actually, good. But I was gonna say that like something that would be like super high yield on the test that it shows up in.
Oh, in like amino acid like synthesis.
So a peptide bond, right?
Yeah.
So definitely need to be able to like connect these topics, right? So like a peptide bond is an amide functional group. Because like basically it's like a peptide bond is like what we can call it in like bio or biochem, but in organic chem we can be more specific and call it an amide. So everything you want to think interdisciplinarily, you don't want to think like so like for this question, it's like you don't want to think just orgo. You want to think like, pretty much everything. But yeah, and when you have a fat, you're gonna have an ester bond, and for your glycosidic bonds, you'll have remember the hemiacetals and stuff and the ketals. So all that stuff that you need to have down. Um, so okay, so your ether doesn't have a carbonyl group, right? So it's like it's not going to be related to a carboxylic acid, right?
Mm-mm.
I mean, like a ketone and an aldehyde have carbonyl groups, and they're not carboxylic acid derivatives, but they're at least a little bit more similar than like an ether. Typically, an ether, like, and you won't really see ethers that much on the test. Like, they could use it as a non-polar solvent. Um, but yeah. So okay, so I wrote, so this is the amine, and then this is the anhydride, and then one of the products we get is an amide. So maybe we can say something like this, and then it's the byproduct, right?
Yeah,
So,
so
yep.
I was gonna say, wouldn't the byproduct be carboxylic acid?
Um, yep,
Oh no, no, not the byproduct, the other product.
yep. Byproduct is, just another name for a product. With just the implication that it's not like your target. But yes. Because this would attack here, move this here. This breaks off, right?
Mm-hmm.
Just like what I wrote here. And so this guy just becomes that carboxylate ion, right? So like O minus and that, right? Very good. So, and like this is like a very representative MCAT question where it's not just asking about the reaction, but we need to take that information that we had to figure out ourselves in the reaction to now apply to the separation technique of extraction, right? So, so we're trying to now separate these two, right?
Mm-hmm.
And so we would want to take advantage of some quality that's different between the two. And, they could have differing solubilities in different types of media. Um, Now, for all these choices, we want to like kind of identify like, how they're different from one another. Um, so what I'm trying to say is that this part and oh well, never mind about that. So okay, the first so A and C, first step, add sodium hydroxide, whereas B and D, first step, add hydrochloric acid. And they're saying it's to quench the unreacted anhydride. Um, tell me about that.
Um, See, I don't know if that makes sense, because it's not in the products.
What part?
The anhydride. Because it's the question's asking about,
Oh,
well,
oh yeah, okay, good question. So, sorry, I overlooked this. So they're telling us it's an excess amount of
okay.
carboxylic acid anhydride.
Hmm.
So we actually have a third thing here, which is the unreacted anhydride.
Oh, okay. Well then I guess like it'll create like carboxylic acids, is what HCl will do.
You're saying, sorry, what were you saying?
Well, I figured it would like protonate the oxygen in the middle, maybe, or like,
Uh, so the acid anhydride is going to be like pretty. I mean, it's not a strong acid, but it's still a type of acid, right? So it wouldn't likely like adding at so like if so like yeah, I guess if you think about like okay, we need to separate um an acid anhydride from something else. Um so if we added more acid, that won't help us like get rid of the or I shouldn't say get rid of, but we want to like neutralize the acid anhydride. And so if you used a strong acid, like it's not going to be very likely to like protonate like that oxygen or anything like that. But um but you could I guess you could think of um just that if you like okay, let's say that we started off with HCl instead of the acid anhydride. What would you use to neutralize it?
HCl.
Um, if you had HCl as your thing,
I would use like a base like NaOH to neutralize it.
yep. So, uh, so yeah, same kind of concept here. Your acid anhydride is going to be somewhat acidic, and
Okay.
yeah,
I don't think I don't know why it didn't register to me that anhydrides were acids too, or like acidic.
yeah, because they don't really look like acids, so that's fair. But this is just like some content that you just have to know,
Yeah, for sure.
and you'll see them also like in that link that I sent you of that the website that I sent you because the website goes over like in a very, very like concise way, like how uh like what these like how these molecules form and like what um characteristics they have. So, okay. Now, yeah, so maybe we can um see that if we want to quench the unreacted anhydride, we can use a strong base, right? So we can get rid of this and this. And so now they say to add the strong base. And now what's different is that this is saying the amide will be in the ether layer. Oh, well, that's the ether you're thinking of. Like most time, like the only time that you'll see it will be like when it's used as like a solvent, as a non-polar solvent. So, okay, so A is saying that the amide will be mixed or soluble in the ether layer, whereas C is saying that the amide should be in the aqueous layer. Oh, and then I guess here they say evaporating the solvent, and then here they're saying neutralizing with um, HCl, which is kind of weird because they don't have HCl in this. Um, but aside from that, what can we do to determine like, that the amide can be in one layer and then what would be in the other layer?
The carboxylate ion
Yep.
or yeah.
Yeah. So now a good question would be that the amide isn't really non-polar. Um, like it does have some polarity to it, uh, but it's going to be relative. So if a polarity means a partial charge, then a full-fledged charge will be even more polar. So this one, since it's charged, it's going to be that that's going to be the one that's in the aqueous layer, and the amide will be in the ether layer.
Okay.
Mhm. So, so yeah, so this was a good question in that it made us have to use the wording to figure out, okay, what is reacting with what. We had to use our knowledge of carboxylic acid derivatives. Um, and then we had to use our knowledge of extraction as a separation technique. Um, and yeah, pretty much all of that. So yeah, so I'm writing down like yeah to go over the derivatives and the biomolecules just to have those down. But yeah.
Okay.
Mhm.
And then like this one kind of tripped me up a little bit. Like
Oh yeah, this is um
is it Kirchhoff's law? Like the loop rule?
oh yep, you do use that. Um so like I doubt you'll see like you so I doubt you'll see like a circuits problem like this involved. And this is one where pretty much everyone, you know, gets this wrong. Like I've gone over this question a lot. Um so like yeah, so the loop rule states that the sum of all the voltage drops across a loop around a loop um, is going to be zero, which essentially means that the voltage gets used up for each loop. And so one loop could be what I wrote here, I drew here in green. And the other one, I'll just use pink, can go through this way. Now,
Okay.
like, what can you tell me about like circuits?
Well, V equals IR, and there's and um current and voltage.
Okay,
Um,
so voltage is like the energy stored per coulomb in this battery over here.
mm,
And there's a separation of charge in the battery that can only be fixed through the electrons traveling through the wire. Now, over here, you have a junction, which means that, so let's say this is this I is the current. When it hits the junction, it can split into, let's say that's I naught, and let's say this is I one, and then this is just I. And like I naught must be equal to I plus I one, right? And now here, is that a junction?
um, yeah.
So, um, tell me about like how you know, or
Well, I assume that the current will like go down. Like well, I guess not, because you were just saying that the current could only travel in those two loops. So probably not. Because I mean, like if it went like here, like this way, like I don't think it could do that. That's what I was thinking, but I don't know. I feel like maybe never mind.
oh, sorry, I draw that again.
It's like, oh, like the current
Uh-huh.
could go here,
Uh-huh.
but I don't know. You were saying that it was only two loops, so I was thinking maybe I was just doing too much because I'm like changing up the direction of the current as well.
So that can certainly happen. Um, but the thing here is that this voltmeter here is so like okay, let's say this is a circuit. Um, I'll just do this. So the A in the circle is called an ammeter, and it measures the current that can go through that resistor. Okay. Now, since it is measuring current, it needs the ammeter needs to be in series with the resistor, right?
Yeah. Yeah, that makes sense. Yes.
And the now the resistance. So if the battery like stores that energy per charge, and and then electricity is the movement of those electrons, when the electrons like basically brush up against the material that the resistor is made of, like the electrons, if you imagine like this is like an atom of the resistor and this is an electron, they brush up against one another, producing friction, which uh causes energy to be released as heat, which is why like, things like, your laptop battery gets hot and stuff like that, right? And so that's what really resistance is. And since we want to store energy, or sorry, we want to conserve energy in that loop, that means that some of that voltage gets used up as you go through the resistor. Now, the ammeter is supposed to have a resistance of 0 because otherwise you would be losing some voltage or some energy through that ammeter.
Yeah.
Now, I also drew a voltmeter, and I drew that in parallel because it's supposed to measure the voltage across that resistor. Now, it looks like a junction, right?
Hmm.
It looks like it can go here and there, but you don't want it to do that, which is why voltmeters are made with a like an infinite resistance.
Okay, that makes sense.
Yeah, because otherwise it would like want to go through it. So here, like for all intents and purposes, like that would be like a junction. But since it's a voltmeter with a resistance of infinity, the current won't travel through it. So the current will just go from R1 to R2 as if they were in series, right? Okay, cool, cool, cool. And basically, with the loop rule, okay, so let's say that the, how should I set this up? Okay, so the voltage that goes through resistor 1, I'm going to call V1. And the
Okay.
voltage that goes through resistor R, I'm just going to call V. And oh, and then there's one more thing. So they're saying that the voltmeter reading is 0.
Yeah, I was just looking at that.
Yeah. So so that makes our job a bit easier because we can then know that there is no difference in voltage between this and this, right? So I can then equate the two. So let's say, uh, the voltage across R is just V, right? So, I mean, like the technical way would be like V, let's say this is V naught minus V1 minus V is equal to 0. But I'm just like adding these on both sides to make it the setup easier. So I have this, and then I can say the voltage across resistor 1 is current 1 times resistance 1, and that's equal to current I resistor R. And now I can do the same thing for these two resistors. V2 is equal to V3, current 2 times R2 is equal to current 3 times R3, right?
Hmm.
And now the thing is that your the current that travels through resistor 1 is the same as the current that travels through resistor 2. So I could say, I could put a star, that current 1 is equal to current 2, right? And I could also say that the current that goes through resistor R is the same current that goes through resistor 3. So I could say current I is equal to uh, current um, 3, right? Okay. Now, what I can do is I can do like a system of equations and cancel out the current terms, which are equivalent. And if we didn't know that that's what we had to do, we could see that the question choice, the answer choices don't have current in it in any of them. So okay, so we could do I'll do like a system of equations, right? Which means I'm gonna just basically like divide one equation over another. So I'm
Mhm.
gonna do I1 R1 is equal to IR divided by, and then I'm gonna put this in. So I2 times R2, and then I3 and R3, right? Right?
Mhm. Um, yeah.
Okay. And now since I1 and I2 are equal, these can cancel.
Yeah. Okay.
And since I and I3 are equal, these can cancel, right?
Mhm.
Yeah.
Yes.
Okay. So then I just get and okay, we're asked to find R. So now so this would look like R1 over R2 is equal to R over R3, right?
Mhm.
And now to find R, I just multiply R3 on both sides to get that.
Gotcha. Okay.
Yeah, so you likely won't see a circuit question this involved on the test, but uh just want to make sure that you like understand, I guess, circuits in general and like the difference between series and parallel and I guess like yeah, the Kirchhoff's rules. So makes some sense.
Yeah, it makes sense.
Okay.
Yeah. I feel like that was it. I just need to look at that, but um, yeah, maybe we could go over the quick sheets. Would probably be.
Yep. So I have also the Jack Weston one, which is pretty much just like this, but it looks nicer.
Okay.
It's
Is
in
it?
the shared drive.
I actually saw it and I was thinking it was cuter, but I was like, I felt like no one was talking about it. That's why I was like,
Yeah, because it's not freely accessible. Like I
Oh, okay.
have it because I used to work with them.
I see. Well, let me have that then. Like, why? I just hate when my computer is slow. Okay.
Um, yeah, it's a common thing because uh for some reason Macs only give you like 8 gigs of RAM, which is like enough for like opening like having like 3 tabs open. But
Yeah,
most people have like a lot of tabs open, which is fine, but these computers don't have enough RAM. Like they really are not good with that. But um like for my like laptop and stuff, like I just, I get the RAM separately and I put it in, and then my desktop is my main thing. Um, which I built, so I have a lot of RAM, a
nice.
lot of monitors as well. I actually have four monitors.
It's
And I have
cool.
7 hard drives.
Yeah, I definitely have been struggling with the RAM thing. Like, I feel like they've been asking me to close out a lot of close out windows because I've been like trying to work and like study at the same time.
Yeah, here's like one of the Yeah, one of the RAM stuff. But yeah, I was always really into computer stuff. Like I built my first computer when I was like 11.
Oh,
Um, and the one that I have is a trooper. It's basically the one that I have is basically on at least 12 hours a day, every day for like 7 years, which is great.
yeah, that's crazy. I feel like I don't know, the Macs don't last that long. I feel like I have to buy a new laptop like every 3, 4 years.
Yeah, that's part of the bit. So, planned obsolescence.
Yeah.
It's basically that. Yeah.
Yeah. Oh, Apple. I'm like they got me in a chokehold though, just because of like I don't know, I just feel like everything
Yeah,
saves.
they make it so there's a huge like in-group like you know uh culture to it. It's like if someone doesn't have an iPhone and they message you, it shows up as like a really ugly green color.
Yeah, it's not
And
cute.
like it's funny because like when people tell me that, I'm like, but do you understand? It's not because of me, it's because of your phone making it that color. But
Apparently you can change it. I seen like in the new updates, but you have to like go into like all the Apple settings and stuff like that.
yeah, yeah. And Apple customers don't really know how to do that stuff, which is why they go to like whatever the Genius store and stuff. But um, yeah.
I was gonna ask, like, is this that important, like chemical kinetics? Like, I feel like I was stressing about not knowing it too much, but I haven't seen it come up that often in my practice tests or practice questions.
Yeah, so this stuff less so, but this stuff, yes. So for
Mhm.
instance, let's say I had this. What order would this be?
Second.
So it would be third order because the this yeah.
Yeah.
So sorry, you cut off, so I don't know if you said anything or whatever.
No, no, no. I said I'm like, where's the third? But you know, it's fine.
Well, that's the thing, right? Because there doesn't need to be one because if you understand what these look like, because look, I'll show you another example. What order is this?
Second.
All right. So how were you able to figure that out? Because this doesn't show it like that.
It's the exponents. It's to the one.
Uh-huh. And then what do you do with them?
What do I do with them? Like oh, add them. Yeah.
Yep. So you see how that's second order, but they don't have it given like that, right?
Mm-hmm.
So, but that fits in with everything I've been saying, which is like it's not about like, what you know or what you're given, but like what you can figure out. And yeah, pretty much that. So good. Good, good, good. So yeah, so to answer your question, like this, less so, this, yes. Oh, and then they can ask a question like this. Like let's say we have A and B in different amounts. So like let's say when A is this, B is this. And then let's say when A is this, let's say B is this. Um, what order could that be then?
Um, Third, maybe.
Yep. Because so like if this so from this we can see that it doubles.
Mm-hmm.
And then here we might see that it doubles, but well, actually, there. So okay, you're right in that I was trying to go for that, but I realized that this doubles, so I'll add one more thing. So when this is this, and that is that.
Okay, then yeah, yeah. I feel like
So now we know that it's, A and then B, oops, squared, right?
hmm
So yeah. So they like I've seen the math questions like that. So yep, so that's what's important for that. And then of course all of this Michaelis met like this stuff, you know, you would have to know, um but oh wait, sorry. No, I just meant like the Michaelis-Menten curve.
Oh, okay, yeah.
Yeah. But like approximates, yeah, don't worry about that too much. Um, all right, cool.
Okay, let's see what we got here. This is just thermodynamics.
Okay.
Mm.
Oh, remember we talked about something like that recently?
Yeah, I was just looking at it because I was like, oh, is this the one that he was saying is water? Is like based off of water?
Oh,
Probably not.
I think it was like something like that, but
Oh,
like so I guess they made it a straight line because just to make it so because the thing with water is it's the exception like because nothing else works like that, so maybe they made it like a vertical line like that. um but tell me about um what is it? Okay, so let's say that we have this to this.
solid to gas, is sublimation.
Very good. And that.
Uh, deposition.
Mm-hmm. And let's see. What can this point uh be called?
Melting.
Anything else?
Um, what's another word for melting? Is it condensation?
Well, so think about so going this way, you would cross that point, but also going this way, right?
Yes.
So what is it called when you go that way?
From liquid to solid is freezing.
Mm-hmm. So melting point and freezing point are at the same point, right?
Oh, okay. Yeah, yeah.
Mm-hmm.
Okay. Yes, that makes sense. Yes.
Good, good, good. This way.
Mm, gas to liquid. Um, is it vaporization? No, no, no. That's liquid to gas. Um, not quite sure.
So let's say you you get like a cold like soda in the summer.
Oh, so is it condensation?
Uh-huh. So what's happening is the water vapor in the air, which you can't see, can touch that cold drink that you have right there, and then uh turn into liquid.
Right. Okay. I remember
Right.
that.
And then your triple point is that point that's like basically the intersection of all these lines. And then your critical point is basically the very, very end of the entire line thing. And basically beyond that point, there's no real difference between liquid and gas.
Gotcha. So like, should I think about it like a kind of like a steam room?
Which part?
Like I guess like the super critical point, like when it's just like super duper hot that it's like gas and liquid at the same time.
Um, you're saying like in you said in a
Well, yeah, like a steam room, like where it's like just super duper hot and it's like, but it's just like all steam, but also like super duper like wet. I don't know. I
I
was just trying
yeah,
to like
I think
figure out a
that.
way to remember it. It's like
Oh
what?
no, that you're doing exactly what you should be doing, which is thinking, um, and um, well, yeah, maybe. That's a good question.
Right. Okay.
Uh,
Well, I feel like I just need to memorize the names of the gas laws. I know they asked about Henry's law, but I don't see it. Is it because it's for like blood? Oh, here it
um,
is.
oh, it's just the one that is. Let me see something. Okay, apparently, uh, in the steam room, it you still have the vapor and humidity. Um, and humidity is really like liquid droplets of water in the air.
Mm-hmm.
So apparently that's not super critical, but I'm trying to like think of like what examples there would be, and I think that it's basically examples that we don't have that we don't see in our day-to-day life. Like I looked it up and I get that it's used in like nuclear reactors and stuff like that. So
Yeah.
yeah, but that's a good question, you know, and you should be thinking like that. Like thinking about real life examples. So okay, so yeah, for these, um, kind of annoying because like the combined gas law or ideal gas can let you deduce Boyle's law and Charles' law and this guy's law, but I've seen them ask questions like specifically like what's Charles's law and stuff like that. So that could just be like a thing that you have to Anki.
Mm-hmm.
Um, now Henry's law is oh, there it is down here.
Yeah.
But that's the one where the concentration of the dissolve like if you apply it to liquids and not just to gases, it can be like the higher that vapor pressure, the more of that gas being dissolved in that in the in the liquid.
Okay.
Mhm.
Mm,
Oh, and then the difference between real and ideal gas, like, don't worry about that. But basically, the idea behind an ideal gas is that you treat the molecules of the gas as not having any volume, and you treat the molecules of the gas as if they didn't have any intermolecular interactions or bonds.
gotcha.
Mhm.
So neurons. So I feel like ideal gases, they're not really in real life, IRL.
Yeah, so a good so like all the way up there on the top they say that an ideal gas, yeah. So real gases can act like ideal gases at low temperature and high pressure. Um which is kind of like a weird I think it's easier to think about it like instead of like that, which is kind of like backwards or whatever, to think about what situations would make a real gas behave like an ideal gas. And that would be high temperature, because if you have high temperature, the molecules are moving so fast they don't get a chance to interact with one another. And also low volume, because if there's low volume, they can be far away from each other and also not interact with each other.
Okay, so
So I just imagine like a gas in space.
for real gases.
Oh no, for ideal.
Okay. So they're not like, okay, low pressures. They're not like colliding with each other. Ideal gases.
Yep.
Okay, my bad. I don't know why it's like this. I thought it would just be like one page.
Oh, that's
It's a
weird.
little,
Oh yeah, there you go. I guess you had it on book reading mode or whatever.
I don't know. I was just trying to make it bigger so I could like see more, but I don't
Hmm.
know. Let me, okay, this is probably the best way.
Okay.
Okay.
So we got your colligative properties when, you have solutes. And so you can get your boiling point elevation, freezing point depression, osmolarity, and osmotic pressure. Um, and it should also say vapor pressure depression.
Hmm. Oh wait, no, it's right here.
Oh, there it is.
Do I need to know like the solid solubility rules like super in depth?
Oh, that's a good question. So, like, it could be something that you can Anki, but I don't think it's going to be like super high yield. Um, like I never really like completely like memorized them. Um, but what I do know is that some of the or okay, so maybe this can help. So it typically, if it's a like cation with just a plus charge, like a plus one charge, it is soluble in water, but for ones that have two plus, a lot of times um they're less soluble in water.
Okay.
But like,
But this is soluble though. The sulfate is
oh yeah,
soluble.
yeah. So that's with a
Minus.
minus. But magnesium is super, super whatever soluble. So, but aside from that, like I just think of like mostly I think of like barium and calcium because I had a biochem professor who said calcium in water or whatever turns into like a rock or something like that. But yeah, I wouldn't say that these solubility rules are going to be too high like high yield enough for you to worry too much about them.
Okay. Yeah, I feel like what I'm realizing is like super high yield is a lot of like the OChem stuff. I did learn about like the sugars and like how to name them and stuff like that, so I feel like I got that down, but I
Oh
just need
yeah,
to.
you should look at the that stuff. I think you can go to like the contents page and then go from there. I think it's clickable. Yeah, so like separation, yeah. Oh yeah, there you go. Yep.
Mhm.
Yeah, so yeah, this stuff is like very, very high yield stuff. Um, so for instance, oh, they should say something like an acetal or something. But yeah,
You see, maybe it's like in the OChem section.
yeah.
I feel like I got this down. Like I know what the anomeric carbon is and all of that. I just need maybe it's over here.
Oh yeah.
Yeah. Oh wait, no.
Mm-hmm. Mm-hmm.
Yeah, here it is. Okay.
Yeah, and knowing like that generalized redox thing, I think they have it here. Like for
Yes.
instance, like if you took a primary alcohol and you oxidized it, you'd get an aldehyde. So yeah, so that's something good to know. Oh, here it is. Your hemiacetals could be your reducing sugars, but your acetals and ketals are non-reducing.
Yes. I remember that the Tollens.
Hmm. Yeah, silver mirror.
Mm-hmm. Mm, okay. Trying to think. So these are all the derivatives here.
Uh oh yeah, yeah. So we have our acid halide, our amide, anhydride, all of that stuff. Um, so yeah.
Mm. Wait, oh, what's like the Hill coefficient used for?
Oh, so that's to measure um so
Mm.
something like this.
1 second. I just need to find somewhere else to go real quick.
What's up?
I'm getting kicked out of my room really quick, but I just need to see if there's another one open. Okay, I'm gonna go to,
Oh, I didn't know you were at UPenn.
that's where I work, yeah, for Penn. So yeah,
Fancy.
just read it. Mhm. Yeah, you know, I'm definitely lucky. That's great. Ooh, I'm just like, if you saw someone was booked earlier, why would you book this one? There's so many
Hmm.
other ones open.
Hmm.
I just was like, thinking on the fact that no one else books like this late. Like I feel like I'm always like once
Hmm.
I book a room, I keep it for the night.
Hmm.
But I'm just gonna go to 19.
Hmm.
Mhm.
Yeah, it's this one's more hidden. Back to the sheets.
Mm-hmm.
Wait, so you're talking about I was talking about the Hill coefficient thing.
Yep. So basically what I drew here, well, let me draw it a little bit better. So like this typical, Michaelis-Menten like logarithmic curve here is gonna have a Hill coefficient of let's say 1. Um, and then if your Hill coefficient gets to higher than 1, the curve turns more into a sigmoidal curve, something like this. So we could say like here the Hill coefficient's 1. It could also be like point 2. It can't be 0, but basically between 0 and 1, like including 1, it'll take on, like I didn't really draw it well, but that. Like the typical, like the one that we just saw in one of those graphs with Michaelis-Menten kinetics, right?
Mhm. So,
Yeah.
okay, so if the Hill coefficient is less than one, then that means that it's the enzyme isn't working, kind of
Oh
like,
no.
or
So so from let's say point like 1 to 1, the enzyme's kinetics are gonna just look like a normal Michaelis-Menten curve like this. But once you get to a Hill coefficient larger than 1, it starts to take this sigmoidal or S shape.
okay.
And that's caused by cooperativity.
Oh, okay.
So like myoglobin would have like a Hill coefficient like that's at most 1, whereas like hemoglobin, since it has cooperativity, will have a Hill coefficient larger than 1.
Okay, that makes sense because yeah, you would want for it to be super cooperative, especially like with hemoglobin and
Mm-hmm.
my
Yep.
okay, that's cool. All right, I that's cool that there's a connection with that, like with the Michaelis-Menten graph and like I guess it's like it's yeah, it's basically just like extended.
Yep. There's all yeah. So that's there's always going to be connections and yeah, I put a picture in. Oh wait, this doesn't have the Hill coefficient, but like for instance, like well actually I guess like there could be the negative cooperativity for like values that are less than 1, and and that just means that it like kind of flattens out sooner. Um Here, let me just get a picture that explicitly shows this. Okay, here. All right.
Oh, that sounds nice.
Yeah. So I guess I was saying like yeah, between like 0 and 1 is the same, but uh it's more so that like for these, they're negatively cooperative, which means that it'll like quickly the curve will quickly flatten. And then if it's at 1, I'll use green. It'll be more like that. And if it's greater than 1, it'll take on more of that sigmoidal shape. Yeah.
Nice. Okay.
All right, so gonna have to wrap up, and I would say to yeah, try your best with the wait. Oh, did we talk about the rest of the section bank?
No.
All right, sorry. That was a different student that's also taking their test. So, okay. Yeah. So I would say just for like the rest of, today, just and tomorrow, just do passive review, like peruse this. Um and then like, if there's something that you want to see, like, okay, how much of this do I need to know? You can look at the content tabs in the spreadsheet. But yeah, I would just say to like passively review this. Um Oh yeah, and then I wrote the stuff I wrote down, like make sure you get those Orgo stuff down, like the carboxylic acid derivatives and ketones and aldehydes and amides and all that stuff. Make sure you know your separation techniques. You could just look at this cheat sheet. They have it here too. Um, and your biomolecules, know those inside and out. Like,
Those are like the functional groups, like the
correct.
and stuff like that.
Yeah, yeah. So like monosaccharide would have like a hemiacetal or a hemiketal, and those could be reduced. And then like a glycosidic bond would be no longer hemi, it'll just be an acetal or ketal, and that can't be reduced. And no, like generally, like, okay, if you oxidize a primary alcohol, you can get an aldehyde. If you oxidize that, you can get a carboxylic acid. So just have that stuff down. But yeah, just basically look through the quick sheets, do some Anki, make sure get enough sleep. The night before your test, people always have really hard time falling asleep the night before their test, so just go to bed like 2 hours earlier than planned.
Yeah, I was planning to call it at like 7.
Yep. Yep.
Uh, I was gonna wait, so where did you like write the stuff down? Did you put it in the is it in like
Oh no,
my
no, no. Just like in my notebook, I just
oh
wrote carboxylic acid derivatives and biomolecules.
okay.
Um, but yeah, you've come a long way,
Wow.
and your scores markedly improved. Like, you know, like with like the 500 like minimum, which is already like 11 points higher than, what you got the first time around. So I think you're gonna crush it, and I wish you the best of luck. And let's see. So there was like I overcharged. Sorry for overcharging you last time. It was like 126. Or no, no, no. Wait, sorry. Hold on. Oh, subtract 24.
Gotcha.
So it'll
Uh yeah, no, I think I'm fingers crossed I could get like 4 more points on my exam.
hmm
Yeah, I think I'll do well. I just need to keep a level head and make sure that I'm focused. That's all.
Yep.
Okay. And
So it'll be 112.
112. Gotcha.
And
Okay.
yeah, yeah, just dial everything in, peruse all this stuff, and yeah, you've come a long way, so you're definitely gonna do really well. Um, And yeah, it's been a pleasure.
Yeah, no, it was nice meeting you. Hope you
Hmm.
have a good summer. And yeah, good luck.
You too. And yeah, when you're done, go enjoy enjoy yourself.
Yeah, I'm so
Enjoy
overstudying.
yourself.
It's been too much effort. I mean, like it's worth it for sure, but I'm just like, I'm so like I'm just
Yep.
tired.
Yep. Yep. All right. Take care, okay? Good luck. See ya.